Hey there, this is Will, and this is going to be a video on page, start that again, on page 394, and this is going to be problem number 2, and this is going to be about indirect proofs. So let's just get started here. Problem number 2, um, kind of goes like this, right? Here's premise number 1. G or H, then not G, therefore not G. Sorry, therefore not G. Well, I mean, a really good question is, how do we get to this conclusion, from these premises, without the antecedent, right? We do not have the antecedent, right? No antecedent. Well, in many cases it's very hard, and in particular it excludes us from using a rule called modus ponens. Um, so indirect proof allows us to kind of to do a couple things, and so let's just see what that does, right? So number 2, indirect proof, you start by negating the conclusion, so that makes it not G. To the side here, we're just going to write IP because we don't number our lines, and I'm just going to mark it as the conclusion. But if this conclusion actually had a number, you would just put the number like you do any other justification for some valid move. All right, well, with not G, it seems like there's a rule called modus tollens that gives us neither G nor H, right? Or not G or H. And that would be line 2 and modus tollens, right? With after using modus tollens, we can just kind of use De Morgan's, and all of a sudden we get this not G and not H, and that's by 3 and De Morgan's. That's one of De Morgan's theorems. Remember, there's 2, and then 5, by simplification, we get not G. We get not G, right? And that's by 4 and simplification. So just keep that all in mind. When you're looking at these indirect proofs. But then, I mean, to see that it actually works out to be a little bit shorter, I'm going to try to prove this directly for you as well, just so you can kind of see how it works here. So let's start with premise number 1 again, which was either G or H, then not G, right? And then the conclusion was therefore not G, right? Hope that's kind of legible. There we go. Okay. Well, proving this directly, I would start with implication, right? And that gives me not G or H, or not G, right? And that's line 1 by implication. Then by De Morgan's again, sorry, we used De Morgan's last time. By De Morgan's, like we used in the first proof, I get not G and not H, or not G, and that's line 2 and De Morgan's. And remember, there are 2 versions of De Morgan's for our purposes. I'm just going to scroll up here a little bit. All right, so line number 4, and me kind of thinking ahead, I'm just going to go ahead and commute this. Not G, and you'll see why in a minute, or not G and not H, right? And that's line 3 by commutation. And then line 5, I'm going to use distribution, right? So that becomes not G or not G. Sorry about that. Not G and not G or not H. Or not H. And that's by 4 and distribution, right? So, sorry, it's getting a little messy here. So then by line 6, I'm just going to get not G or G down here by simplification, right? This is 5 and simplification. And then by the rule tautology, I'm going to get not G, right? And that's 6 and So that's kind of how you do it. I'm just going to scroll up so you can see this. Now there's not much of a difference really in terms of what how many steps. I mean, there's like 2 extra steps or something. But if you notice too, I really kind of had to employ some more complicated rules over here in this. And this really was a little bit more complex. Oh, that's not legible. It's more complex. And that's not legible. Okay, maybe I just won't write it. So this is just a little bit more complex over here, and there are definitely more steps. And one thing we want to do is minimize the steps for efficiency in proving things. And this is one way that you do it, and I hope this was helpful.